Okay, so this is for 6.04 reciprocal power functions. And so it's just basically we're taking the reciprocal of a function. And so we can obviously we can have different functions. We can have 1 over x, 1 over x squared, 1 over x cubed. And so those are the power functions, just taking the reciprocal of them. So if we wanted to graph like 1 over x, I'm just going to draw a t-chart here. So we'll have an x and a y. And we're going to have, if x is equal to -3, taking the reciprocal of that will give us -1/3. If x was equal to -2, we would have -1/2. If x is -1, y would be -1. If x is -1/2, then y will be -2. Let me draw this down further. If x is equal to -1/3, y will equal -3. Okay, and then at 0, we're going to be undefined. Okay, so let's just draw the negative portion. So let's do -3 is -1/3 there, -2 and -1/2, -1, 1, 1/2 would be -2, 1/3 down to -3. And what happens is we have values that we can never really get to. So it's going to look something like this. If it'll let me draw it here, hold on a second. Let's see. Oops, excuse me. So let's see if it'll let me draw here. So we're going to have what are considered to be asymptotes. It's never really going to reach the x-axis, and because we're always just going to be getting to a smaller fraction. It's never going to get to 0, and it's never going to get to the y-axis either. Okay, so let's look at the other side of this. Let's look at where the values are positive. Got to find my... Oops. Okay, so we've got if x is equal to 1/3, y would equal 3, and 1/2 would give us 2, and 1 would give us 1. 2 would give us 1/2, and 3 would give us 1/3. So let's graph those. So I have the point 1/3, 3, 1/2, 2, 1, 1, 2, 1/2, 3, 1/3, and so we'll have the second kind of thing here. Oops, and there it goes again. Sorry about that. And it will look something like this. It'll go this way. Never really reaches that line, even though it's hard to tell that it's never reaching that y-axis. It never really reaches the x-axis either, because remember, we're always cutting it into the 1/2, 1/3, 1/4, 1/5. It'll never reach 0. Okay? Now, something that is interesting about this is we refer to these things, they are called branches. So let me just highlight here. This is one branch, and this is another branch. Okay, now with the y, where it's undefined, okay, we will have a vertical asymptote. Okay, so it will never reach that y-axis in this case. So we have a vertical asymptote right here, and we will have a horizontal asymptote right here because they'll never reach the x-axis either. And so here, just with explaining it a little bit more, here are the definitions. Okay. And you can see horizontal would be y is equal to something, and the vertical would be the x is equal to something because it means the x never changes. Okay, so what we want to do is we want to determine the domain and range of a function. And so here, if I have this function 3 over x squared, well, we know that x cannot equal 0 because if it does, then we're left with a terrible thing of having 0 in the denominator. So for our domain, we're going to have that the set of x such that x is an element of real numbers. Okay, and that is the abbreviation for real numbers, but x cannot equal 0. Okay, now all other numbers we can plug into that x squared term. Okay, so now then if we are going to look at the y values, this is kind of another interesting thing because in this case the y values are dependent on that x, but the x is squared, and since the x is squared, it will will never have negative values here. So that's kind of interesting in this respect. So we know that y is going to be greater than 0, or the y values will all be greater than 0, and that is our range, okay, the value for our range. And so we'll have y such that y is greater than 0. Okay, now let's take a look at the g of x function down here. And so our domain, again, we cannot let x equal 0. So we're going to have x such that x is an element of the real numbers. Okay, but x cannot equal 0. Okay, now the range is a little different here than it was up at the top. We're going to have y values, and the y value will be elements of the real numbers as well. Same thing up here. They're elements of the real numbers such that y would be greater than 0. But in this case, y can't equal 0, but it can't equal negative values because if we plug a negative into x and we cube it, we do end up with a negative number. So here we're just going y cannot equal 0 either. Okay, so there's no number that you could plug in for x that would give us a 0 for y. Okay, so then we have the reciprocal power function, and this is the graph families. And so if we look at the right-hand side, this is a parent function of 1 over x cubed. And look and see what happens if we do change the function a little bit. We if we multiply by a fraction like 1/2, then we're going to move closer to the asymptote. Whereas if I have the 8, if I multiplied the a by a larger number like 8, we move farther away from the asymptote. Okay. And so here's parent function, here it is changed in two different ways. Okay, notice also that this one was multiplied by a negative, so this one actually caused the function to flip, okay, or be reflected across the x-axis. Okay, again, here's a parent function of 1 over x to the 4th. Okay, and if you change the parameter for a, so here are the red ones, they multiplied by 8, it moved farther away from the asymptote of the y-axis, but here with the g, they moved closer, and they were also flipped across the x-axis, so they were reflected. Okay, so if we wanted to graph a simple power function, it's not too difficult. As it says, it's simple. And so let's just take and graph the first one, the 1 over x squared. So I know that if x is equal to 1, then y will be 1 because 1 over 1 squared is 1. If x is equal to 2, then I have 1 over 2 squared, which is 1/4. Okay, and if x is equal to 3, I would be even closer. It would be at 1/9. Okay, and then if x is equal to 1/2, that would be 1/2 quantity squared, which is 1/4. Take the reciprocal of that, and I would get 4. Okay, this gives us a curve that we can work with here. So I've got something like this, okay, for the that branch. Okay, now for the other branch, let's take a look at it. And I'm squaring the terms, so it's going to be a little bit different. If I have the -1 and I square it, I will end up with 1 for my y value. Okay, and so all of these are going to actually be positive values. So if x is equal to 2, then I would, or excuse me, -2, then I would have 1/4 for y, and then -3, I'd have 1/9. So, and then the same way here, I would be up here to 4 if it was -1/2. So then I can draw this branch. Okay, again, remember it never reaches these asymptotes. Hold on one second. It's not wanting to let me draw tonight. Let's see if I get, there we go. Okay, now if I do something a little different, I multiply these things by 1/3. Okay, so let's change colors. Let's do a purple. And so now if I have 1, if x is equal to 1, I have 1 times 1 over 3 times 1, which will give me 1/3. So x is 1, I have 1/3 here. Okay, if x is 3, then I'm going to have, well, let's not do 3. 3 would be bad. If x is equal to, let's see, for my g function, okay, purple here. So if x is equal to 1, we saw that y is 1/3. If x is equal to 2, then we will have 1 over 3 times 4, which is 1/12. So we're getting much smaller. If x equal to 1/2, we would have 1/2 quantity squared, and we will end up with 4/3. Oops. Okay, so it will end up with like 1/2, 1 1/3. And so we're going to have something that will look like this. Here. So see how it's gotten closer to the asymptote, and then we would do something similar over here. Okay, there's a really nice pretty diagram of this in your textbook. And so then here that we have the asymptote would be x is equal to 0. So which is the y-axis. So we can't have x equaling 0. It'll never approach that. And the last thing that we need to do, so if the graph of the function has the following, has a vertical asymptote at the y-axis, okay, and they will have the horizontal asymptote at the x-axis. Okay, so if I've got one more problem that I will need to do, and that's this problem, and it will be on a separate recording.